And so that's that long tail, incredibly long tail, is actually dust and ice particles. And what you're looking at when you see a comet is you're looking at the light reflecting off those dust particles that are coming off the comet. Well, when it goes around, a lot of stuff's getting knocked off that comet. Comes around the next time, a lot of stuff gets knocked out. And it doesn't come back. Once it gets knocked out, it doesn't come back to the comet. It's gone into space. It dissipates. So these comets, if you estimate, how old could they be? They keep getting degraded every time they come around the sun. It's estimated that short period comets, most of them couldn't be older than, say, 10,000 years. So there's a lot of methods, I'm just mentioning several, that give young ages. But I don't think we really know from looking at things exactly how old they are before human observers. We can't really know for sure. So I'm not going to really rely on that. The thing I'm going to rely on is what Jesus did. And if he says, if he's believing this, then I'm going to say, I'm going to believe it. That's probably right. I'll probably go with that. Anyway, so what were we going to do next? Oh, let's do. Anybody got another question? Or I will go to. I'm going to do a little thing on the flood right now. Unless somebody have a question, a follow-on on this one. No. Okay, good. So the flood. Peter talks about the flood. Jesus talks about it, and they all seem to believe that it's an actual thing that happened. Interestingly enough, yeah, you can start there. The flood. Oh, by the way, let's talk a little bit about fossils and the age of them, but remind me after the flood, okay? So, actually, almost so many cultures around the world have stories of a worldwide flood, and I don't think that's a coincidence. By the way, the Chinese character for boat, which is one of the oldest languages in the world, is a character for words, right? Chinese have characters for word. The character for boat is actually boat plus 8 people. Well, why did they pick 8 people on a boat? Why is it 8? How many people were on Noah's Ark? 8. Yeah, why is one of the oldest languages in the world kind of have the character for boat having 8 people? Why do all these stories have a lot of similarities to the biblical story about a worldwide flood? Why is it? Why isn't it fire? Why isn't a volcano destroyed the earth? Why are all these stories having floods? I think people are going back to these memories. But let's talk about a little bit about the flood. And if you read the Bible, it says it's saying it destroyed all living things. So that is an incredible flood, by the way. So I took well, let's go back to the Grand Canyon here. Do you got the Grand Canyon here? Because that's that one before that too. So in 1986, I hiked into Grand Canyon with a bunch of geologists, and yeah, that's okay. We'll do that. So the Grand Canyon has a whole bunch of layers in there. It's about a mile deep. It's about average 5 miles wide. And who's been to the Grand Canyon? A couple of people? It's incredible. If you get to go to the Grand Canyon. The thing about the Grand Canyon is it's not really unusual geologically. The unusual thing about the Grand Canyon is it's in a desert and it's cut so you can see a mile of rock. So right here you can just see, the rock you're standing on. But in the Grand Canyon, you can look at all this rock a mile down. So that's what's unique about the Grand Canyon. But if you look at it, if you go down to the Colorado River, you will see one thing about the river. Anybody ever seen pictures of the Colorado River, like people rafting on it and stuff? You've done it?
Yeah.
Now, what color is the Colorado River, usually?
It's muddy.
Muddy.
It's
very muddy.
Particles of rock in it.
There you go. Here's a man who's been there. He's testifying that it is.
It's rocky.
It's muddy, particles of dirt in it. The river is brown. So that tells you that what's going on upstream? Erosion, right. There's lots of erosion happening. All that mud was once rock, and it's been eroded, and it's in the river, and it's going down the river. Now, the river's dammed up at many places, so it kind of slows down the flow of the river now. But the mud is going down and eventually emptying into the Gulf at the end of the Colorado River. But the point is, there's a lot of sediment going down there. Now, if you take samples of the river and average the amount of sediment in there, and you take the water out and evaporate it, and then you measure the volume of the mud, dirt, rock that's going down that river, you can do that fairly easily, straightforward. And we also know exactly how fast that river's flowing. We got a lot of dams on that river. They know, let me tell you, those engineers, they know how many cubic feet per second, and they know it really well. So we know how fast it's going down and how much dirt is going down. Guess at current rates of flow on the river, average flow rates, even with all the dams and the slowing up of the river, guess how long it would take to erode the Grand Canyon? 5 miles wide, 1 mile deep, 200 miles long. Basically 1,000 cubic miles of rock. Guess how long it would take? Anybody have a guess? No, it's not that fast. No. Otherwise, it would be double the size every year, right? But it's about 71,000 years. 71,000 years. So it couldn't be older than really 71,000 years. And there's lots of evidence in the canyon that indicate that there was a lot more water in there in the past at some point in time, and the erosion was much faster. And by the way, when it rains a lot and the river's up and the flood level is higher, there's calculations done, and it would only take 11,000 years at those rates. So the canyon's really pretty young. And we look at the sides of the canyon, and you can see. Let's go to the last one there. No, the one before that. So I didn't do this in the first one. I'm just doing different things, guys. So anyway, let me see if I can. I don't know if you can read that, but you can't read it. Okay, so I'll read it for you. It says, basically, this is like 15, 20 layers. That's like a mile of rock in the top layer of the Grand Canyon. And all these brown ones, basically, Kabye Sandstone Formation, near to offshore shallow marine shelf. Toro Weep Formation, near to offshore shallow marine shelf. Coastal, what does it say? Coastal something, salt flats and stuff. You've got Coconino Sandstone. Now that's debatable. They say windblown sand dunes, but really there's lots of evidence that these are underwater sand dunes. That's the only layer that even is any question. Every single one is underwater, estuary, underwater, offshore shallow marine, tidal channels, offshore, underwater. Every single layer in that mile of rock was formed underwater, and usually under a shallow sea. Now, if you go to the park and they explain and they have the video that you watch, they'll say that, well, there's a shallow sea and then it went out, and then there's another shallow sea and then this went out, and then there's another shallow sea and went out. But that's kind of a little bit more complicated explanation, because 1 mile of rock was laid down underwater. Think, interesting. A lot of sediment laid down underwater. And by the way, if you look at the layers, you can look at the picture there. You look at these layers. Next one, yeah. A picture of the Grand Canyon. You will see that each of these layers is actually pretty straight across. There, do you see any V's in there? Any cuts in there? Big V's cut in there? No.
Perry.
You don't see any. It's all flat. Now, right here I'm going to talk about something right there, but all these layers above is a mile of rock, and they're all flat. And by the way, you can find the same layers 1,000 square miles, over 1,000 square miles. You go to Bryce Canyon, you go to Arches National Park, you go to Zion National Park, you'll find the exact same layers. And they're flat. And there's nothing, there's no erosion, no river valleys cut between them. Well, if the Grand Canyon was cut in less than 11,000 years, and there's no canyons cut in any of these things, there's no river erosion, no nothing between these layers, how could they be very old between them? Because you would have erosion happening fast, and you got none. So that indicates that all these were really laid down pretty fast, without any erosion between them. And this layer right here is very interesting, because can you see how these rocks go at an angle below it? Everybody see that? See how it's kind of shaved off? It's like moved, tilted, and shaved off, and all the upper ones were laid down like pancake on top of them. Everybody see that? Yep. So that is very interesting, because you can see it in the Grand Canyon. Now, if you were hiking and you were looking this direction, you wouldn't see it. But you have to come over to the side where you can see it. But you can see that in the canyon. And that's what's interesting about, you can see it. But this is found all over the world, and it is called, because the top layers are flat, they don't conform to the bottom layers, which are at an angle. It's called a unconformity. That's what geologists call it. They give a complicated word, unconformity, because it doesn't conform the top layers to the bottom layers. But this unconformity is special because it's called the Great Unconformity. Why? Because it's found all over the world on every continent. And even more interesting than that, below the Great Unconformity, the rocks have no fossils, none. There are no dead things in the rocks below. And all of a sudden, above it is the Cambrian. Below it's Precambrian, above it's the Cambrian. And guess what? An explosion of fossils. There are tons of fossils in even the first layer above that rock layer. Why? Why do you think that is? Well, what happened? Why is there all of a sudden a whole bunch of fossils in a whole bunch of rock that had to be laid down pretty quick, all of it underwater, all over the planet? What do you think? Got any ideas?
Fossils are dead things.
Fossils
right?
are dead things buried under sediment and a lot of water all over the world. You got any ideas? You know, scratch your head a little bit.
Lots of things die all at once.
Lots of things die all at once. Very interesting. But here's the obvious thing right in front of you, and you know, you miss the whole big picture sometimes. But these geologists that I hike with gave many more evidences of why this is evidence of really a massive worldwide flood. By the way, go back to the dating of organisms. What time is it right now?